Happy Monday. There we go. All right. Last time we left out, it said we were on slide 28. Technically, this is slide 28. So, kind of going back in from our question of the day, right? Steering knuckle. Again, I have to emphasize this. The steering knuckle is going to be a solid piece of metal where pretty much a lot of different systems are going to be all linked together. So not only is this a suspension system component, it's also part of our steering system component. It's a steering system component. It also is where our brake calipers are going to be mounted to. All right. Our drivetrain, depending on if we have a front-wheel drive vehicle or not, is going to be running through this. So a lot of different components. This is the main part of our vehicle, even though it's not part of the chassis. Okay. It is also considered to be unsprung weight.
Amazing.
It's unsprung weight. What's unsprung weight? Not supported by the suspension. Okay? So this is going to be traveling up and down with the suspension just like a tire or wheel or any other components of the suspension system. Alright? As you can see here, let me just kind of get in here. Here's my steering knuckle. Could have a strut or a shock absorber. I could have my rotor for my brake system, my wheel hub. Right here I'm going to have a brake caliper attached to this. I'm going to have a tie rod for my steering system in that. Okay, both there. And then down here I've got a ball joint that's attached to it. On that particular example. This one here is a rear steering knuckle, although it doesn't really necessarily turn. It's set up a little differently. Okay, this would you'd actually put the bearing on here, right? Lower control arm, upper control arm, upper and lower ball joints. You know what I mean, Juan?
Yeah.
Yeah. Okay. So steering knuckle and the wheel spindle. Okay. It's forged into a single component. So if this particular component breaks, it's not something you would normally end up going down to a parts store and pick up, right? It's probably you're going to the junkyard and you got to pick up a part off of a vehicle itself. Just kind of the way that goes. And typically these are not going to break, right? Because they're a single cast piece of solid metal. Now, if there's a way that we could lighten that steering knuckle up, it would lower our unsprung weight, which means we would have a much quicker and faster actuating suspension system. So that's something that you could theoretically modify. All right, today we're going to get into a little bit more on ball joints. Okay. So again, ball joint is a technical term. It's a definition, something you're going to want to make sure that you're going to need to know not only what it does, but also how it performs and why we would need it. Ball joints are wear items on vehicles. Over a period of time, a ball joint will wear out and will need replacing. Okay? But typically speaking, our ball joint is going to connect the steering knuckle to the control arm, just like we talked about earlier. Okay, this is going to allow the knuckle to pivot on the control arm during steering. So again, this is an image of what a ball joint looks like when it's not installed. Here it is actually installed on our lower control arm. If you were to cut this in half, what you would actually see is this threaded rod here goes in, and there's a little ball right there, just like that. That's why it's called a ball joint. This is set up to be very similar to your shoulder joint. Okay? Your shoulder joint is a ball joint, if you were not aware of that. So not only can my arm rotate like this, but I can also move it around this way as well. Okay? I can move up and down, across. I can rotate all around as I'm twisting and turning. Okay? That's what allows you to give you the range of motion in your shoulder with your arm. Simon.
So, how many miles does it take for these to just destroy themselves? Because
What, the ball joint?
yeah, because my dad has 250,000 miles on his Volvo, and
Don't know, right?
perfectly fine.
So, don't know. Some can last 250,000 miles. I would probably say maybe every 100,000 miles would probably be 150,000. It's something that you're going to have to just inspect and keep an eye on, okay? A lot of the times, on modern day vehicles or higher end vehicles, ball joints are good for the life of the vehicle. if certain things are met, okay? One of those things is right here. It might be a little hard to see on this particular one, but there's a rubber boot that kind of covers up the ball joint. And if that rubber boot is intact and in good condition, that's going to keep all the grease and everything on the inside there, but it also keeps any road debris, dust, dirt, water, gravel, things along those lines, Jonathan, out, okay? So if that's in good condition, it's probably still good. All right. Now, again, part of the inspection process is to visually look at this rubber boot on it, and if it looks like it's cracking, tearing, ripping, whatever that may end up being, obviously then you need to denote that. It doesn't mean the ball joint's bad right then and there, but it's allowing contaminants to get in, and it will ruin that quicker. So that's part of the visual inspection. Secondary, we would want to go in with a precision measuring instrument like a dial indicator, and we can actually measure the tolerance that's in between the ball and the socket, and if there's any movement within a certain degree, then that would cause for replacement or need for replacement. Okay, even though it might look good, we could come back with that type of measurement. Some vehicle manufacturers, they say if there's any noticeable movement to the naked eye, ball joint needs to be replaced. Others will actually go in and say, hey, we expect 5 to 10 thousandths of an inch movement. At that point in time, it's out of compliance or out of the tolerance, and then that would mean that it probably needs to be replaced. Okay. And by the way, if your ball joint does go bad on your vehicle and you don't replace it, you're driving down the road, very, very bad things can and will happen. I got a story behind that because I was at Devil's Lake a few years ago, and a person's ball joint gave out as they were driving the parking lot. It literally took their entire wheel and just went right into the chassis of the vehicle. They were going like maybe 10 miles an hour. Imagine that happening on a highway. Woo.
Ooh.
Yeah.
Sounds like a great.
It would not have been a fun trip for them. Actually, it wasn't a fun trip at all because they needed to call a tow truck. All right, ball joints are mounted to control arms in one of 4 basic ways. Okay, they can be attached by a rivet or rivets. More often than one rivet, right? It's usually about 3. They could be bolted in. I've seen a lot of them that are press fit, or they could be threaded. Probably the most common type is press fit. This is where the ball joint is produced and it's actually put into a control arm, pressed in there. These are typically ball joints that are not going to be removed. You literally would have to end up buying a new ball joint and a control arm at the same time. And that control arm probably also has new bushings because that probably also needs replacing. So in fairness, yeah, the part's going to be more expensive. Yes, you're going to get more parts than probably what you were thinking about. But you know what? It's probably overall better for the health of the vehicle, for maintaining it, because now you're getting a whole bunch of new parts and components that's going to work with the ball joint in order for it to succeed. Okay, so that's a good thing. And again, on here you can see a whole host of a variety of different shapes and sizes to ball joints, but they all work the same. Okay, it allows that control arm to move up and down, actuating with the tires, and the steering knuckle is on top of that, and this allows the steering knuckle to turn and flex up and down at the same time. Okay, so it's kind of doing 2 things at once. Now, if you are lucky to find a ball joint that maybe is bolted or threaded or riveted in, well, at least threaded and bolted in, you could just theoretically buy just the ball joint, unthread that, unbolt it, pop in the new one, and you could install it that way without removing the bottom part of your suspension system. A rivet, those are not something that you would normally be able to replace. You could remove it, but installing it would be a different story. You would have to have some specialty equipment for that.
Another rivet.
You're right. Okay, this is very important that you get down in the notes, you draw some pictures, because not only are you needing to be able to identify a leader and a follower ball joint for the lab, but there's going to be a question on the test straight up. I will ask you, is this ball joint a leader or a follower? You must know this. Okay? So, ball joints are either going to be a leader or a follower. A load-carrying ball joint generally mounts on the control arm that holds the bottom or the seat of the spring. That is how we are going to define that. Okay? A leader ball joint is a load-carrying ball joint, and it is generally mounted on the control arm that holds the bottom of the spring.
And that's the leader?
That is the leader. Okay? It is a load-carrying ball joint. Now, on the next couple slides in the future, we're going to talk about two different kinds of leader ball joints. Okay, I'll give you that information right here if you want to put that in your notes. But we can have either a compression or a tension type load-carrying ball joint. Again, we'll get into that in a little bit. Okay. So in this case, we're gonna start coloring things in and drawing this so it makes a little bit more sense to you. Okay. Here's my lower control arm. Okay. Here's the bushing. This is where it's attached to the frame of the vehicle. My ball joint right here. Here's my steering knuckle. And I got another ball joint up here on this control arm. So this is a lower and an upper control arm. Both have ball joints. My bottom ball joint is considered the load-bearing or leader ball joint. Why is that?
All the load.
Because that's where all the load is passing through. Okay, and again, the spring is passing through that. Okay, now in this case, we can't see the spring probably because it's a torsion bar system, so that means it's going out that way. But if I were to kind of come in here and say, okay, the shock absorber, the load is going to go transfer from the chassis through here into the tire, into the ground. You guys see that path?
It's crazy.
Okay, same thing here. This is my chassis, it goes through the spring, goes through this ball joint down into the tire through the ground. That is where the load of the vehicle is passed through. The forces are enacting through that location. Okay? In this case, because this is the top of my spring here, the force goes through here and into this. So it bypasses that ball joint. Let me redraw that just to make sure it's not confusing. Come on. Come on. No? There we go.
There.
Almost there.
Almost there.
Okay.
Oh, I got it.
So again, our lower control arm ball joint, in this case, this one and this one is a leader. This one it is not. It is a follower simply because the load of the vehicle does not pass through that ball joint. Okay? So that would be a follower.
Amazing.
So again, here's just another illustration of what that looks like. So I've got two examples here. Let me pick a color here, red.
Purple.
So here's the top of my spring. This is my chassis. This is my strut tower. This is what is supporting the vehicle up off the ground. that force is transferring through the spring, through the upper control arm, through that ball joint, into the steering knuckle, and then basically down to the ground. So which one of these is going to be the load-carrying ball joint? Upper or lower ball joint?
Top one.
Upper ball joint, because that's where the force is traveling through. On this particular one, let me move over on this side here. Top of the spring is right here. This is what's supporting the weight of the vehicle. That force is going to travel through the spring, through the lower control arm, into the steering knuckle, and then down through the tire into the ground. So, where is the leader or the load-carrying ball joint in this case? The lower ball joint. Trace the path of the force. You can identify if it's a leader or a follower. Okay, so in this case, again, let me just pick a common color. I got a ball joint down here. That is a follower. This ball joint up here is a follower. Okay, it follows the lead of the leader. Okay, the load carrier. Okay, does that make sense?
Yeah.
Okay. Okay, so again, load-carrying ball joints. We're just talking about load-carrying ball joint, leader ball joints. They can be classified into one of two ways. They can either be a tension or a compression loaded ball joint.
Looks like one's just upside down.
It does, but it's how the ball joint is held in place on the vehicle.
Wait, is one tension, one's compression?
Yes.
Oh.
So in this case, what's tension? Tension is like tug of rope. Tension is being pulled apart. What's compression? Compression is pushing together. All right, if we look at this particular one, this is a tension ball joint. So this steering knuckle is actually trying to move upwards. The lower control arm is trying to move downwards. It's being pulled apart. So this ball joint, you can see here, is being encapsulated. The shoulder is actually up above this. It's because it's trying to be pulled apart. That's where all the forces are going to be going that way. Well, technically speaking, let me erase that quick. Right?
Which is more common?
It depends. Depends. I would probably have to say probably a compression.
I think drop the AirPod.
What?
Or like what funny thing? It also depends on the manufacturer.
It depends. It depends on the configuration and the arrangement of the suspension system. All right, this one, the lower control arm is trying to push down, steering knuckle is trying to push up. So there's your compression. And again, this shoulder now is here.
I don't know if he thinks it from the back.
Guys, you talk so much. If you guys want to do that, go to study hall.
Yeah.
All right, anyways, depending upon the force of the load tends to either push on or pull on the ball joint to keep it in its socket. Follower ball joints are said to be friction loaded. Okay, so again, we're talking about leader ball joints, load bearing ball joints, tension, compression loaded. A follower ball joint is friction loaded. Okay, you know what friction is? Okay, I know that's kind of a category of ball joints and then a subcategory, but again, we want to make sure that we can identify that. Now, on the lab and on the test, I'm not going to necessarily ask you guys, oh, is that a tension ball joint or is it a compression ball joint? Because the only way you're going to know is if you actually kind of just think about the process of how is the forces acting on the suspension system as it's traveling down the road. Is it important to be able to get a tension ball joint if you will go to replace that? Not necessarily, because you gotta find the right model number of that. So there's all that. All right. Here's the big key thing when inspecting ball joints, and most people get this wrong. Okay? You can't just simply look at the ball joint and go, oh, it's fine. Now, again, we would do that if we were inspecting just the boot around the ball joint. That would require a visual inspection and a go, no-go check based off of your experience. Right? Hey, that's cracked and it looks like grease is coming out. That's bad, it's torn. We got to keep an eye on that because over the next 10,000 miles it's probably going to go bad. However, if we're testing the internal components of that ball joint, we must make sure that it is loaded with, the joint must be loaded and moved with a suspension wear indicator tool in order to properly check for looseness. So this is a key factor for the lab when we go in the shop. You're going to get a dial indicator. You're going to put that onto the ball joint that you're going to be checking. You then need to load up the suspension. Basically, you're going to put the weight of the vehicle on that suspension system so the force is going through the ball joint. You are then going to take something like a pry bar, and you are going to actively be trying to separate or compress, depending on if it's a tension and compression ball joint, and you're trying to pull that apart. You're trying to pull the ball out of the socket, move it around, check for looseness. As you're moving that with the pry bar, you're taking a look at the dial indicator to see how much it's moving, because that is an indication of its looseness. If it's moving outside of the specification that the manufacturer wants, it's a dead ringer. You just say needs replacement. If it's moving but it's still within the tolerance level of what is prescribed, it's a good ball joint, right? You can go back to the customer and you can say, hey, we did an inspection. We are 100% confident that your ball joint is bad or good. And here's why, right? It's evidence that you've provided. It's not just well, we kind of think that maybe your ball joint's bad. Let's just replace all of them anyways because it's like $1,000 and we just want to rip you off. We're communicating our professionalism and our educated knowledge of what we know to somebody that doesn't understand that. We want to build trust because that's how you're going to allow them to come back and say, okay, listen, I don't know what's wrong with my vehicle. I know that you're going to tell me what's wrong, and you're not just going to try to like take more money from me when it's not necessary. Okay? It's like building friendship, right? Hey, I got a bunch of friends. I'm just going to constantly lie to them. Right? I'm constantly going to steal their time and their money and all that sort of stuff. How long do you think you're going to be friends with those people? Not long at all, because they're going to be like, listen, don't invite this person over here because they're always lying. They're always cheating. They're always stealing. What do you think about in regards to auto shops around Fond du Lac? You go to some place, you find out that they're lying to you and trying to rip you off. What are you going to do?
Eat them up, sue them.
No, why would you waste any kind of money trying to sue them? Right? How many auto shop repair places are there in Fond du Lac? More than one? More than one? Awesome. Go to the other person. They're probably honest. And you know what? They might be a little bit more expensive, but people will pay for that just to know that they're going to trust them. And they're going to do the job right, too. I can't emphasize that enough. So anyways, this particular individual is showing you how we would load it up. We have a jack underneath there. We've actually raised up the weight of the vehicle that's on the lower control arm. And then we're taking a pry bar here. We're actually going in between the floor and the tire and actually trying to lift up on that to create looseness. But again, typically speaking, you're going to have a dial indicator unless the manufacturer specifically says, hey, any visible movement at all indicates that a ball joint is bad. Okay, then you probably wouldn't need a dial indicator. Again, some tolerances for ball joints are so small that you're not going to be able to see the difference with the naked eye. You need a tool like this. This is called the dial indicator. Dial indicator. Must be used to check for looseness or play. If you are not aware what a dial indicator is probably one of the most useful tools in an Autotex back pocket, just like a digital multimeter would be for checking electrical stuff. We use this tool all the time. Okay, you're gonna learn how to use it on this lab. You're also gonna be using a dial indicator when we talk about brakes after we get back from spring break.
What does it do?
Okay? It is literally measuring movement. Okay, it's got this little needle right here. It's a little plunger. So we put this on a surface, and if this particular needle moves up or down, however much, this needle or this indicator is going to fluctuate back and forth. And we can actually make measurements and say, oh, there's a measurement of 20 thousandths of an inch,
How big is it?
right? I don't know, it's
Which
like
manufacturers
kind of
tend
like
to
a
be
watch.
pretty picky?
Say it again?
Which manufacturers tend to be picky about like no?
It depends. It depends more probably on the vehicle and its requirements. Some of the older Fords, like I think the Ford Probe, is just any visual movement that you can see with the naked eye, which by the way is a ton of movement. Sometimes you'll get like the Chevy Malibu out there, it'll pretty tight tolerances, like 5 thousandths, 10 thousandths, and it's shot, which is crazy to think because you're not going to visually be able to see that. You put a crowbar on that all day long, you're going to be moving that up and down. It could be totally bad, a bad ball joint, but it looks good. Okay? Anyways, dial indicator must be used to check for looseness or play. Ball joints should be checked for both axial and radial play or movement. There you go, there's 2 other words. Okay? Axial is basically that direction, radial is that direction. Okay. If I'm seeing that correctly. So again, we're looking at a ball and a socket, so I can go this way and I can go this way. I don't want either of those. I want it to be nice and tight. Okay, if there's any looseness in that. And again, there are various different tests that we can run to check for radial and axial loads, which means I would have to take my dial indicator and put it this way for axial play, and this, put it on that end for radial play. So the positioning of this dial indicator is very important depending on what test that we are running on that. Yep, there we go. So you can see here pictures of that. Radials back and forth, in and out, axials up and down. Radial play is measured at a right angle to the joint center line. Axial play is measured with a dial indicator on the same axis as the center line of the ball joint. Again, this is a definition here, right? If I want to know how to measure axial play, whoops. How do I check axial play? How do I check? Where's that at?
Does the car have to be in the air to check test it?
Sometimes you can have it up in the air. Sometimes they want it just off the ground. Depends on where you're prying from, right? Now, in a lot of cases, since we have a lift, in a lot of cases it's very difficult. Like this particular picture, I would not set up my dial indicator the way that they have it set up, because if I'm grabbing the whole of that tire and I'm trying to shift it back and forth to check my ball joint, I'm not just checking my ball joint in this particular setup, I'm also checking my wheel bearing, and I can't be doing that. I can't be trying to check 2 things at once, because I could have wheel bearing tolerance issues, and then, oh man, the ball joint's bad. I replaced the ball joint and come to find out it was the wheel bearing the whole time. So I gotta make sure that I have to be smart in regards to where I set up my dial indicator, so that way I'm just checking the ball joint. You can't just whimsically throw this on here and then expect to get a result. If you don't do it right, you're gonna get a wrong result. So in a lot of cases, what's gonna end up happening is we're actually gonna remove the tire, So that way we can actually have access to the top of that. And then we're probably going to end up putting this on the side. Again, shimming that back and forth can be a little trickier. Going up and down is a little easier because I can get underneath something and just try to move the control arm up and down a little with the pry bar. The radial is a little bit trickier to perform. It's possible, it's just takes some setup time. So again, when are we talking about the lab? The lab is really easy. You're just going out there and you're doing visual inspection, you're setting up the dial indicator, you're just doing a couple measurements, okay? Generally speaking, probably should take you maybe 10-15 minutes to do. The reason why it's going to take longer than that is because of all the setup time. It's going to take you a half an hour to set up the dial indicator and about 2 seconds to actually do the test. It's like the wheel alignment system, right? When you guys went out there, the actual procedure to set things up, roll the car back and forth and do all this sort of stuff took basically the entire hour, but then it just spat out to you the results and you just kind of had to copy that down. It's going to be similar here. This is going to be very frustrating for you the first couple times you try to set up a dial indicator. Okay? Hopefully by the end of the lab you guys can get really good at it because you're going to go, okay, I need to put it here. This is how I do that. And if you can get this set up in 5 minutes, it goes much faster. But it's a learning curve, right? Trying to figure out exactly how to do that. So that comes with experience. Okay, we're gonna end with this slide here today. So if a ball joint, boot, or seal is damaged, again, this is from a visual inspection. I don't need any type of specialty tools to do this. I need a flashlight and my eyeballs. Okay? If I notice that my boot is torn, or the seal is damaged, right? Here's a torn boot. That is exposing that ball joint to water, dust, debris, gravel, dirt. It's on a road, right? It's going to get in there. And if it gets between that ball and that shoulder, it's like a mortar and pestle. It's just going to start grinding away. Grease is going to come out. Okay? It's going to decay. It's going to rot. It might not be bad right then and there, but it's going to be. All right? Again, any types of cracks and stuff, if you notice any grease that's spewing out or weeping out of things, there are ways that we can re-add grease, but typically they're sealed from the factory. Okay? All right, don't put your notes away yet. We're going to give you guys 5 minutes here at the end of class. Again, we're going to use this time to write down any particular questions that you might have specifically about ball joints. Okay, what was confusing? What did you understand? What would you like to know more of? Do you have questions about axial play or radial play? How to set up the ball joint, or excuse me, how to set up the dial indicator? Are there different kinds of dial indicators? What questions do you have? Again, with the expectation that you're not necessarily going to answer those, it's just trying to allow your mind to start processing the information and solidifying it in your head. Okay? We're going to end the presentation here.